Is the human brain truly the most complex object in the universe? Or does the cosmos outshine it in terms of complexity? This question poses a compelling conundrum, a cerebral puzzle that has sparked much debate among neuroscientists and astrophysicists alike. On one hand, we have the human brain, an intricate labyrinth teeming with roughly 86 billion neurons, each with the potential to forge countless connections. This neural network, some argue, is the epitome of complexity, the pinnacle of intricate design. Yet on the other hand, we have the cosmos. The universe, with its vastness, its unknown quantities, its unexplored mysteries, presents a challenge to our understanding of complexity. But what is complexity? Is it simply a matter of quantity, or is it more about the unpredictable, emergent properties that arise from simple elements interacting in complex ways? And if so, do general laws govern this emergence, transcending the boundaries between the cerebral and the cosmic? These are the questions we aim to explore, the threads we hope to untangle in our quest for understanding. So, let's dive deeper into these perspectives and try to unravel this mystery of complexity. First, let's consider the human brain, a marvel of nature with 86 billion neurons. This intricate organ is not merely composed of an astounding number of neurons, but it is the vast network of connections that truly illustrates its complexity. Each neuron can connect to thousands of others, creating a web of interactions that is as mysterious as it is remarkable. This means that the number of possible neural connections far exceeds the number of atoms in the known universe. Now, these neurons aren't just aimlessly interacting. Each connection has a very specific role to play. They are responsible for everything that makes us human, from the primal instinct of survival to the higher cognitive functions, such as thought, memory, and consciousness. The brain's architecture is not just about quantity, but also about the quality and diversity of the tasks it performs. The complexity of the brain also lies in its adaptability. It is a dynamic structure that constantly changes in response to our experiences, a process known as neuroplasticity. This allows us to learn new skills, form memories, and even recover from brain injuries. Moreover, the brain is not just an isolated entity. It interacts with every other system in our body, influencing and being influenced by them. This interplay adds another layer of complexity, making the brain a truly unique and intricate object. So when we talk about the brain's complexity, it's not just about the sheer number of neurons, it's about the connections they form, the diverse functions they perform, the adaptability they exhibit, and the intricate interplay with the rest of the body. With all these factors, it's not surprising that many neuroscientists consider the brain the most complex object. But what about the cosmos? Now let's look at the cosmos, a vast, seemingly infinite expanse full of galaxies, stars, and countless unknowns. The cosmos is a grand tapestry of celestial bodies, each with its own unique characteristics and mysteries. Consider the sheer number of galaxies out there. Some estimates suggest there could be around 2 trillion galaxies in the observable universe. And each of these galaxies is teeming with stars, planets, and other cosmic entities. But the complexity of the cosmos isn't just about numbers. It's also about the intricate relationships between these celestial bodies. The gravitational dance that keeps planets in orbit around their stars, the explosive birth and death of stars, the formation of galaxies from clouds of dust and gas. These are all part of the cosmic ballet that adds layers of complexity to the universe. Interestingly, there are parallels to be drawn between the cosmos and the neural networks in our brains. Just as neurons in the brain form a vast interconnected network, the cosmos too can be seen as a network of galaxies linked by gravity. These cosmic structures, like the neural networks in our brains, add to the overall complexity of the cosmos. Yet, the cosmos also holds countless unknowns. Dark matter and dark energy, for instance, are two enigmatic components that make up a significant part of our universe. But we're still in the early stages of understanding them. These unknowns add an extra layer of complexity to the cosmos. Considering its vastness and the myriad unknowns, it's easy to see why many argue that the cosmos is more complex than the brain. But is it really? So we've explored the complexity of both the human brain and the cosmos. But which is more complex? This debate swirls around us like a cosmic whirlwind, with compelling arguments on both sides. Those advocating for the brain highlight its staggering 86 billion neurons, intricately connected in a network of mind-boggling complexity. Yet the cosmos proponents counter with the sheer scale and diversity of cosmic structures, from galaxies to black holes, each with its own intricate patterns and rules. However, comparing the complexity of these two systems proves to be a formidable task. It's like comparing apples to oranges, or neurons to stars, if you will. The challenge lies in the fact that complexity is not a standard unit of measure. It can't be easily quantified or compared across different systems, making this debate even more enthralling. Ultimately, whether the brain or the cosmos is more complex may be a matter of perspective. But one thing's for sure. Both are incredibly complex in their own right, and understanding them is one of the greatest challenges we face.